Hey all, I thought I'd make a bit of a video specifically on our Land Rover spring mounts, whether that be 90, 110, 127, 130s, Defenders, Range Rover Classics, Disco 1s and 2s. They're all extremely similar in their design and implementation, and all based off the original Range Rover Classic 1970. That's where it all started for the core sprung live axle variants of Land Rovers. So two main reasons or motivations to do this video. I'm hopefully more than halfway through modifying my rear spring mounts, spring perches, and also very recently YouTubers Steph and Lee, who some of you may follow or know of as Grizzly and Bear, that's one word, Grizzly and Bear, have had uploaded a video, and they've had this issue for a little bit now where their front spring mount has failed. So just seeing that and thought, oh yeah, I've got some thoughts about it in myself, and also not just why it's happening. I mean, there's some obvious stuff going on there which other people have mentioned, and I'll talk about that with Lee and Steph's, but just more about my thoughts on the load paths and, you know, a bit of information about the chassis and stuff like that I know and will share. And maybe it's interesting, maybe it's just waffle, who knows. If you want to challenge anything I'm saying, absolutely, you know, comment, or just want to add anything that you know or knowledge points, that's great too. Just drop it in a comment, much appreciated. So we'll have a bit of a look at the front, because that's where the main issue is. With Lee and Steph, they're having the bolt holes that they're cracking through the top plate, top flange of their mounts, and it's cracks propagating at this hole and going straight to the rear. So I think it's the rear side. I think it's the rear side that is doing it. I should have paid more attention to that. If we're looking specifically at their failure, we would take absolute note of whether it's the front or the rear side. But this is a bit more of a generalization. Have a look at their video, absolutely. Look at a lot of their videos, because they're just great to see the locations they go to, their travels, their problems. Not that I wish that upon them, but that's interesting to me, and how they resolve them, you know, the choices they've made to suit their lifestyle for the modifications they've done, and, you know, where they are in the world. And you know, it's just good to see that variety. Very interesting, you know, and I'm in the middle of many years of building this slowly in my spare time, and it'll just be for putting around here Australia. So there's plenty for me to see here, but that's yeah, back to the perches. So if we look at the perch, the fronts are made out of sort of three components, let's say. The main mount itself is formed out of one piece of steel. So that's the top, the sides, the stiffeners, this back piece, it's all pressed out of one pressing or form, if you want to say, which is a very good thing. And, you know, even this fold, everything's one piece. The other pieces are the gussets at the back. There's two of those. We'll have a look at those. And the additional overlays here and here to add strength and connection, and importantly, connection. So when the coil spring, and in Steph and Lee's case, the airbag is working, when there's any compression at all through a bump, cross articulation, whatnot, we're getting a compressive force up and into the top flange. So it's pushing up, and then that load's got to go somewhere and be transferred and distributed into the chassis. When that load is let off, and yes, there will be some download because of the dampener, whether it's mounted there or, well, actually it does depend where it's mounted, but let's disregard the dampener for a minute. Pretend there's no dampener or shock absorber on the mount whatsoever, like the rears. Even though there's no real downforce, and again, let's disregard retained coil springs. When the compressive force is let off, there is a reversing, my understanding, there's a reversing of the load paths of the loads, not the load paths, but the loads, and that's fatigue. So even though there's not necessarily a pushing up and a pulling down, the release of the pushing up is a reversal of loads, and that's fatigue. And fatigue is a big issue in automobiles. It's a major problem to deal with, and it's a major design factor. So that's something to consider. There's huge fatigue in shock mounts, dampener mounts, body mounts. It's just a constant battle for designers. And I think Land Rover have addressed that pretty well. The majority of the very few, and I'll say very few, when you consider total number of sales of all the vehicles that Land Rover made that share this design, the vast minority have failed. And the majority of those have been modified. Or that, it could be something to do with rust, corrosion, and issues like that. So they haven't all failed because of poor design. When we are pushing maximum capacity, maximum design criteria for what Land Rover deem use, then we are pushing the limits and we will reduce the life. That's how fatigue works. The higher the load, the less cycles. You can design things to be infinite for a given load. As soon as you go beyond those loads, then that is not infinite. But again, let's just look at the mount itself. So when it's pushing up here, that's a compressive force in the top. That load's got to go somewhere. It turns into a tensile force down here, down this edge of the gusset or leg, if you want to call it. And that's now a tensile force ripping up. It's trying to tear up off the chassis as where spring's pushing up, pushing into the top plate. It's trying to tear that up. In my opinion, the load, a single point load, is probably going to be highest out here. And that being because when you're in cross articulation, not that might be because generally when you're cross articulating, you might be driving slower and therefore the force is less, but the spring compression is more focused on one point. When you're tilting like that, and this wheel here is coming up, and the other one's going down, the coil spring is compressed more so on this outer edge than the inner edge, than anywhere else around there. So that compressive force is high right here. When you're doing sort of fairly flat, it's distributed mostly equally around here. Now, it can never be perfectly equal. The coil doesn't touch the mount perfectly all the way around, and there is no such thing as perfect perpendicular movement. There's the axle travels in an arc because the radius arm's at a fixed point, so it's in an arc. So there's all these little things going on, but for the most part, let's just say in normal travel, it's fairly uniform, and in cross articulation, it's going to have a high point load. The forces are there. This is supported. I'll call this a supported edge. This is supported edge. This is supported edge. All through there to this point here where it's the least supported or not supported. And not only that, it's its narrowest. So that's going to flex more. That's more flexible. That's not good. I think Land Rover did this because they've run the numbers. They know it can handle their design criteria. And two, with the factory shock mount turret, there's some stiffening added to this by way of the turret design. It's completely enclosed. It's got a flange that goes around and it's cylindrical. It's two halves, fairly cylindrical, welded together, but it's solid and it goes up here. There will be some stiffening by nature of that turret added into here. The rear has material around here. The rear does not have a shock mounted to the top at all. So that's some thought process there, or something to think about. So, problem with Lee and Steph is they've got an outboard shock that's still mounted to the top, a huge cantilever, and that's changed the whole dynamic of how the load is being handled. The shock loads, the dampener loads are being handled through this mount, which it was never designed for. If we look at the 1990s Range Rover Classic that came with electronic air suspension, airbags all around from the factory, their shock was not concentric. It was mounted on the front, but it did not attach to the coil spring perch mount. It attached to those four holes. Those four holes are on either side are for the steering box, whether you're right-hand drive or left-hand drive. So they're there on every chassis, and the mounts are left and right. As far as I know, I don't think they're one. I think they're mirrored, so there's a left and right, and that's where they mount. So they don't have that load, that offset eccentric load on the thing. I mentioned that to them a little while ago to take a look at that. My understanding is they're addressing their issue as far as their shock mount goes, and how they deal with that. And I think they're attaching it to their chassis somewhere as well as that. That's totally up to them what they do, and the people helping them. That's their, that's what they're doing. So that's fine. So just the mount itself, we're looking at all good as far as where I think the forces are going. The front mount, spring mount, is higher than the chassis by, let's just say, 50 mil. The rear is not. The front has these extra gussets, the rear does not. Now, these are incredibly important. Land Rover, these little details, it's important that you see these, you take note of them, and you implement them if you have to get rid of them, or if you're modifying and doing a steering box conversion or something, anything you remove and get rid of, you must, I think, reinstate it in some way, shape or form if you can't exactly do what was there. Lee also mentioned that he saw some extra reinforcing on his mount. So he bought his mount from YRM in the UK. Great mob. I've dealt with them. I've bought some stuff from them. Huge range of Land Rover, individual Land Rover chassis, body, mounts, all these things. Fantastic resource for us Land Rover files, and they're good service and good people. So I recommend them. I've got no affiliation. I just pay like all you guys do. I'm a nobody, so no deals for me. He noted that there was some extra reinforcing, and the way I interpreted what Lee was saying, I'll say that again, the way I interpreted it was almost like he thought someone had added that. I want to make it clear that that's factory on the Defenders. I'm not necessarily sure if the Range Rovers had it. I haven't had a Range Rover for 30 years. And again, these gussets, I don't think were on the Rangies, but the early Rangies, but they're definitely on Defenders, so they're there for a reason, incredibly important. So these extra bits are an overlay here that goes under, and this overlay, which is also wider, that goes under. From what I can see, the single formed mount is welded and installed first, and its stiffening leg wraps under and gets welded. Then they add these. And the reason I say that is there's a couple of, you can see the welds. It's hard. I'm not going to probably be able to show you on the video because of things in the way and whatnot, the detail. But, and I point that out because if they've done it, they're getting the required weld length that has been figured out, and that's important, not just to add the overlays and then weld it, okay? So, and if we look at them, and I'll just move my light around here because I'm getting in front of it, try and make it a little bit better. We look at them as the forward and the rear of the mount. This is the front of the car, it's the back of the car. That's not the same width as that. Now, I reckon they've done that because they can't physically do it because of the steering box bolts and all that stuff. I think they would have if they could have. I can't see why there would be forces more that way requiring more here. I think they're compensating a bit for the lack there, and the only reason they haven't done more there is because they physically can't. That's my guess, okay? So I could be well and truly wrong on that. Regardless of whether I'm wrong or right, and comment if you've got an understanding, though what I'm saying is those pieces are important and they're crucial. And if I was doing an install, and we'll talk about a little bit about my backwards way of doing my rear ones, but if you had to cut all that off, clean the whole thing up, weld the mount in and recreate those and weld them over. And quality of weld is very critical as well. So the rear web part of the mount has a continuous weld all the way across. It is not welded on the other side where the corner of the top flange of the chassis corner meets it. It's not welded where they butt into each other. It is welded there. The legs or gussets are welded down the inside, not the outside, down the inside. They probably want to keep some weld further away from the holes, and they're doing all this weld here anyway. So that's where they're welded. You won't see it down the outsides. Fully welded down there, and then the flange the stiffening flange or lip folds under, welded there, and then the overlays are continuous welds around as well. Nicely formed. They look a bit rough and crude, but if you tried to form them yourselves, I can tell you now, it's it's not fun. It's a pain in the butt to do anything like that. This here is not a crack, it's a crease, where they have what's called jogging, or again, it's a little step in it. And the reason they've stepped it there is this flange goes under the chassis. This piece of material here is on top of this piece, but that ends there, and then this piece here has been stepped back up so it's flush and touches the chassis. The difference being the thickness, which is, thickness of these is 3.3 millimeters, 3.4. I'm going to say that's either 10 or 11 gauge steel, because in Australia we can't buy 3.3 mil steel, we can buy 3 mil or 3.5, but you can't buy that locally at your shop. So I'm going to say it's like a 10 gauge. Again, why didn't they go for 4? Why didn't they go for 3? 3 obviously wasn't enough. 4 was more than they needed. They've been efficient in their designing, and that's something I give them credit for. And that brings me to the chassis as well. Lots of comments about how thin the chassis are, and they've got thinner over the years, and comments about steel quality. Well, let's put steel quality to bed. Unless you have taken samples of chassis over the years and had them metallurgically tested, we are guessing. We are just talking rubbish as far as I'm concerned. Unless you have seen the suppliers to the chassis manufacturers, and that may have been someone like GKN or who knows that were making the chassis for Land Rover, but I don't think you can say with any certainty, unless you're really in first-hand knowledge, that the material has changed or got worse. As far as the material thickness, from the Range Rover onwards, they've been 2 mil for the main chassis rails, these parts, not the mounts. They're different thicknesses depending on the mounts, but the main rails are 2 mil. All right, and that even states it in the workshop manual. What a lot of people fail to realise is that there is internal reinforcement in many areas, and it's the areas that Land Rover deemed it necessary to increase the strength. Now, why didn't they just make it out of thicker material? Well, that'd be good for a lot of us for certain things, but their mindset was adding strength where it's needed and not adding weight where it's not. Maybe you think, oh, well, that's just a cheap way out. I don't think it was at all, because it required much more labour to do it the way they did it. And if you see here, dots, we'll call them dots, they're spot welds. Spot weld, spot weld, spot weld, spot weld, spot weld, spot weld there. Spot welds all along here. They have formed angle in every corner where it's needed. So there's 4 corners in a box section, and there's 4 bits of angle. And they spot weld those into the chassis halves. Each half is a C. We call that a clamshell design, with this long weld down the middle, top and bottom, continuous. They spot weld the formed angles into the C's first, and also some funny little bits where they need what we essentially call a crush tube to stop the chassis crushing, where you're going to run bolts, or the high tensile bolts, and then they weld the chassis together. So at the front spring area and all this area here and the rear, there is 3 mil steel folded angle in every corner. So essentially at the corners, and let's say it's about that high each one, so this section would probably be completely full, and the flange is almost full as well across. It's essentially about 5 mil thick. Now, is it the same as if it was one solid piece of 5 mil? No. Some people say laminated steel is stronger. In this situation, I don't think it is, because it's only got spot welds here and there. Strategic, and obviously again meets all their numbers, but it's way better than it only being 2 mil, much better, but it's not the same as if it was 5 mil in my opinion. But there is added strength. They're not just 2 mil right through. So don't let that sort of, oh, they're thin as. I can't remember what the series were. Again, it's been a long time since I've had my hands on a series chassis. You know, prior to Series 3, they were 4 sections welded. Having those welds along the corners is a stress riser. There's, you know, there's pluses and minuses to everything, but that's a bit of note on the chassis, and I'm 100% certain of that because I have been inside these chassis. I've cut them up, I've modified, and I've measured with calipers those folds and seen where they are. And actually I can show you where a previous person did a really quality weld of an engine mount and burnt through the main chassis. You can see that there, and there's the material behind it. That is the formed angle, and we come down to that hole and there is no extra angle there. So it tapers off right near that hole, but it runs up through that curved section where high point, high stress load, the 4 angles are there. So that's a bit about the chassis. Land Rover chassis are tall and thin or slender, so good design is crucial for attaching things to the chassis, and we've got to appreciate, or at least acknowledge and do it the way Land Rover have done it. And welding 6mm to 2mm, even though it's got the material behind it, it's still 2mm material, is hard to do, to get the correct penetration to the 2mm and to the thicker material and not burn through the 2mm or get 0 penetration into the thick material. Very, very hard to do. So there's some, and also you've got to think about abrupt changes in stiffness. So as far as modifying the spring perch, Steph and Lee have laminated more 3mm all up here, all across here, and all down here. And he did bring this around a little bit. I'm not sure if he just brought it to here and stopped. I don't think this will do too much. Adding material here under this circumstance, I don't think it's going to do too much. You're not gaining extra welding here. It's still attaching to the chassis the same. And this isn't really a weak point as far as the design. Adding it to the top is great for their issue, especially to resolve it. My personal opinion is stiffening this edge, because it's this flexibility, and when we change stiffness, so we've got a hole here which is a stress riser, regardless that there's a bolt in it, regardless that it's round, we've removed material from a stressed area, it's a stress riser, number one. This unsupported edge coming into here, so we've got a change in stiffness here, most flexible here, narrowest unsupported, slowly getting wider and with a folded edge, stiffer. So we've got a change in stiffness here, and then again another change in stiffness here. It is somewhat progressive, that's great, because they've thinned it out and they've transitioned. It's not just abrupt, but there's a change in stiffness right at that corner where that stress riser is there. 2 stress risers have combined with a shock location and mount that it was never designed for, equals problem, equals failure every time. As far as modifying this mount, potentially the skirt going all the way around and bringing this up a bit further would help. But regardless of the crucial thing is, has it been attached? And I'm not going to comment too much because there's just not enough information on their video. I'm not here to criticize and shit can Steph and Lee. You know, they're doing great, and they really are. But my thing is I hope that there's been some close inspection of how it's been attached, and that they have, you know, reproduced that, and you know, whoever's doing it's taking care not to nick and gouge a chassis, not to go too hot and over penetrate and stuff like that. But that's a bit of thought about the front spring mounts, and you know, potentially why they don't have this lip here. And I'll just show a bit more. These gussets there, fillet weld on the outer sides, not on the inner sides there. Now, I would think that when it's shaped like this, so this clearance will be for the steering shaft and the unis. Normally a gusset like that, there's not going to be much going on. That line would just go straight down. My thought process is they've again calculated the required weld length for this attachment, and that's why it goes all the way back there. Again, Look what Land Rover do. They know the whole dynamic of the chassis, not just individual components. I'd say pay attention to those sorts of little things. This overlapped piece here, again, fully welded around after the mount has been put in position. It has a little bit of weld on this internal corner here. Sorry, terrible lighting. And it is also welded up here. Again, that brake bracket's in the way, sorry guys. That's but that's welded up there. So I will try and show underneath. The bump stop mount's in the way. The phone's probably going to spin around and rotation's going to go off its head, but we'll see what we can see to show underneath. There. So that's the extra little overlay gusset. That's probably where the main stiffener, gusset stiffener comes in. That's continuous there, welded all the way up there and back on that other side. It only comes into here. They've taken it as far as, again, they've deemed necessary. Now they've got longitudinal weld on the first one there and there, longitudinal weld on this one here, and a bit there and there again. So that's in the same direction as the load path, and then this weld here is tying it so it doesn't obviously tear off on the corners. And that load path there is with the chassis, the forces front to rear. So I guess that's okay there as well. And who am I to say it's not okay? It's Land Rover's design. So, but just again, making sure that's noted that this is tied under here. And again, all that is very, very crucial in my opinion. And that one there, again, sorry guys, I'm lying on the back here. Goes under, very similar with a slightly different shape, but it's the same principle there. And you can see that continuous weld there from the web. So those are sorts of key points that are pretty important. We'll go and have a look at the rear, and you'll have to use your imagination a bit here because mine are nothing even remotely stock. I've overlaid mine kind of top and sides like Lee and Steph have, but I did that because I've cut and shunt. Now, I'm going to say the best way to do this would be make a whole new mount from scratch and install it. Unfortunately, this modification came to me that was in the back of my head, and it came to me at the wrong time. It never came out to the front of my head when it should have, which was before I did all of that work. And all of that work's on point as far as alignment, and I didn't want to potentially risk chassis alignment with weld distortion. So I took the course, or I took the direction of modifying the original one. So it is what it is. It's not the best way of doing it, but it's going to be okay. And the reason I've overlaid, even though I did say I didn't think it was going to add much strength to Steph and Lee's situation, is their spring mount is one piece. That's a key issue. Mine, I cut the original top off the gussets. I left the gussets, the stiffeners here, everything in place, and I literally just cut the top off and cleaned everything else up. I then folded up a C section, 3 sides, to create the riser, to increase the height, the distance I want. That's a butt weld. It's a traverse to the load path. It's a butt weld here. So I've got a butt weld here and a butt weld here to the original top and the original gussets or legs, okay? Because those welds, it doesn't matter how good those welds are, they're full penetration. I've made sure of that. They're welded, cleaned out the back and welded on the back as well. They're traverse to the load path. The chances of them cracking under fatigue is extremely high, and that is unacceptable. So the overlay on the sides is so I can attach the original gusset leg to the riser and to the top all in one go. That's why there's all these plug welds here. So this added piece here gives me strength in the top, to increase a bit of strength in the top. this brace at the back, which is again one piece. I'm trying to, as much as there's 3 meters of weld, literally 3 linear meters of weld in these bits I've done, which is ridiculous, but that's what it is. Anything that I can do in one piece and reduce a weld, I've tried to do that. They are helping the now height change cantilever, and they're tied in here. And you'll see, instead of just being a straight across their weld, fingers, probably be able to see this one a bit easier. So we get the vertical-ish welds are in the same direction as the forces coming down here, because welds across the direction of force are less than ideal. So now the stiffeners, the gusset stiffeners ended here, and then this would have been flexible, and that would have been a high stress load or load concentration. And again, there's that weld in there, so that would have been a high point of potential failure. So I've added stiffeners to the original stiffeners in there and brought those up to the top corner on each side. So each side on mine is the same, except for the fact that the bottom of the chassis rail changes, and we've got a nice transition that's not abrupt and across, with tapers down there for those added stiffeners. This front skirt I added, but you can see the old one is literally just there. That line is parallel all the way. There's the original factory skirt to the original factory top. Okay, so this is my added part, and this is the original top with the original formed hole and the original skirt. And I'll show you inside that in a second. The reason I added this skirt was to add a little bit more strength, but more importantly, this point here, where it tied in, forget the stiffener, where Land Rover tied this skirt to the original mount, which was down here, they deemed that important. They actually added some little overlays on the inside that I had to cut through to cut the top off. Didn't want to, but there was no choice. And I'll try and get up under there and show you the remainder of them and where they're welded. So if we look up in there, spin that light around a bit better. Try and zoom in without turning the video off. So, hold my hand still. That piece of material there, and you can see a little bit of weld under my fingernail there. So that height went all the way around to there, and it got cut off up there, unfortunately, and there was no two ways about that. So you can see the factory MIG weld up there. So I reinstated the weld to my new skirt and then up around there as best I could. But there's no way that what's there now is equal to what Land Rover had without all these other bits. And that's because you can see where I've welded that old original formed front skirt, and all they had was a weld in this little corner, because that's the only part they couldn't form continuous. So they had a vertical weld there, and then because that was a high concentration point there for them, they had this overlay, because I imagine the early ones, they suffered fatigue, because I know from friends with earlier Land Rover 110s, they do not have those overlay pieces there. I bet you Steph and Lee's vehicle do in their rear, because the 130s had the heaviest suspension components and some additional gussets in various parts. Trailing arm mounts, A-frame mounts had some little extra gussets that 110s didn't got. The heavy duty cab chassis 110s that come with the 130 rear suspension had the same as the 130, but the 130 got that. Now you'll also see, if I zoom out, that, and I'll try and, it's a bit dirty, but try and get a bit better light. Come on. The leg here comes all the way over and is jogged or stepped over the chassis rail right over to there. Now, again, continuous welds. Now, why would they go to that trouble? That's trouble. That's more money, more material, more welding to do. Now, again, a guess is they determined that that length of weld that's in the same direction was required for the load seen in this mount, and therefore they've gone that far past on each leg. Very important. If you're making your own mounts, wrap them under. You might be able to make them a bit neater and transition this a bit differently or better, but regardless, make sure you at least achieve what Land Rover did there. So they were never welded up the inside here vertically. You can see there's my inside weld there and up the top, 2 points, bang and bang, from my riser, and that's formed one piece. There's no weld in the vertical corner because I formed it out of 1C. Again, trying to reduce welds, which sounds hilarious considering the amount of weld in those things, but here we are anyway. Now, you'll notice that there's only some stitch welding there. That's all Land Rover had with their overlap. So again, I just thought, okay, they know more than me, I'm just gonna copy that. In hindsight, maybe I could have got smart and done my little fingers there because the loads are vertical. These holes are simply just for access for paint and for ongoing maintenance, bit of oils and stuff like that, because it is a confined area. So this is some overlap stitch as per Land Rover. And the other thing that Land Rover did was on the other side, on the chassis side of the spring top, where it came out, they continuous welded it, and you can see my weld line there. Not on the front, but definitely on the rear, so I recreated that. So I welded the tops in first before the overlay, completely welded in. Everything was checked, cleaned up, and this was already on. Then I added the overlay, then I added the stiffeners. And I still have to add little stiffeners down here. They will not box this in. They will not box in completely, and they will not weld to the top of the chassis rail. They're simply going to come down where my finger is and weld to this corner to stiffen this higher load path here. The holes in the back of the brace are again for access for maintenance. Interestingly enough, something that I learned was by adding the little holes either side of the larger holes, it reduces the stress concentration. It doesn't reduce the stress in the material that is given by the forces into it. As soon as we remove the material, we've reduced the strength. It doesn't matter how you remove the material, or if you do flared holes, you've reduced the strength. There's no way around that. Make that clear. But when the forces come down and come around these big holes, the concentration of stress is high here. By elongating these holes or adding little holes, we can reduce the concentration here. So it's more fluid around here. Great little tips. Anything that I can learn and pass on, stuff like that just blows me away. My brain doesn't think like that, and I just think that's so cool. So there's so much thought into engineering design of anything that is moving and suffering fatigue. Well above my pay grade. I'm just lucky to have people that I know, or friends that I know, that are way smarter than me and are happy to answer my questions and put up with my not understanding things. So if any of this helps you guys, that's fantastic, because let's just try and do better. Let's try and make things better so we can be safer and enjoy our travels and our full driving and whatever it is we're doing, whatever it is we're making, and not have that heartache of failure or being let down, or worst case, injury and sadness in families and friends. So hope that's been not too boring, and that you've all got something from it. Obviously there's a lot going on my vehicle that isn't stock. I've tried to make that clear with the rears. The fronts are 100% stock as they are. There's no modifications on those spring mounts as they are. It's a 98 build 110 300 TDI cab chassis. It did not have the heavy duty spring setup or 130 setup. So that's a wagon chassis will be the same. So yeah, any questions or comments, no problems guys, go right ahead. And let's keep enjoying our Land Rovers or whatever vehicles you're building, and have a good weekend guys. Cheers.